Hey guys, we're going to go over the last 4 questions of part 2 on the January 2024 Algebra I Regents. If you want to see the first 4 questions, 25 to 28, I went over those in a previous video. So quick preview of the problems I'm going to explain to you today. We have a quadratic formula problem, we have a piecewise function, we have a completing the square problem, and we have a factoring by difference of squares problem. So let's get right into it with this quadratic formula problem that asks us to solve 3x squared minus 2x minus 6 equals 0 for all values of x. And then we're told where to round to. So if you're thinking the quadratic formula sounds familiar, but I do not remember it, that's okay, because guess what you have? A reference sheet. So please don't forget to use your reference sheet on the Regents. The quadratic formula is there for you, highlighted in yellow. So your first step is to just make sure that you transcribe it correctly. So we're just going to move that formula into our workspace for our problem. And now as I look at the formula, there's a bunch of different variables. And now I have to remember, well, what do these variables even represent? And guess what? If you don't remember that, the reference sheet can help you with that too. So let's take a look back here again. Right above the formula, there's the quadratic equation. So the standard form of a quadratic equation is y equals ax squared plus bx plus c. So if you look at this and analyze it, it should help you realize that the a value is the coefficient of the x squared term. The b value is the coefficient of the x term, and the c value is our constant. So now that we know that, or you might have already known that without the reference sheet, we're going to come back to our problem, and we're going to identify what those values are. So what is a, what is b, and what is c, so that we can substitute correctly into the formula that we have, all right? So looking at the equation above, our a value is 3. Our b value is negative 2, and our c value is negative 6. Don't forget the signs that are before those values. Now that we know what a, b, and c are, we can go ahead and substitute them into our formula. So x equals negative b. So I have negative, and now I have to replace b with its value. Well, the value of b was negative 2. So now instead of writing b, I'm going to write negative 2. So I have negative 2 plus or minus the square root of b squared. Put that b in parentheses. I will explain why later. When in doubt, put it in parentheses, okay? Anytime you substitute a value, put it in parentheses. So b is negative 2, so I'm writing negative 2 in the parentheses, and the exponent goes outside of the parentheses. So that's b squared. Then the formula says minus 4 times a times c. So I'm going to replace my a with 3. I'm going to replace my c with negative 6. And all of this, including the negative 2 plus or minus, is being divided by 2 times a. And my a value was 3. All right. We have correctly substituted all of the values into the formula. Double check, because you don't want to lose points just because you wrote down a number incorrectly. Now we got to get to evaluating this thing, right? So in a minute, I will show you how to just throw it all into your calculator at once. But first, let's do some math by hand and show how we simplify this. So negative 2 is positive 2, all right? Plus or minus the square root of. So negative 2 squared, that means negative 2 times negative 2, which is a positive 4. Now, if you're using your calculator to evaluate this, if you go to the bottom left-hand corner with me, I want to show you the difference. If you write negative 2 squared in your calculator, it'll tell you that it's 4. However, if you forget those parentheses and you just write it like this, the calculator will tell you that it's negative 4. And the calculator would be right, because you're not asking it, in this second case, to square negative 2. You're asking it to square 2 and then multiply that by negative 1. And that's where that negative 4 comes from. So you have to tell the calculator exactly what you want it to do. So if we want it to square negative 2, we have to put that negative 2 in parentheses. All right, and then I can do minus 4 times 3 times negative 6. So that's going to give me plus 72. And all of that is over 2 times 3, so I'm going to write that as a 6. All right, let's simplify a little more. X is equal to 2 plus or minus the square root of 76 all over 6. Don't forget that fraction bar gets extended over to everything. So once I get to this point, I could simplify this radical further, but I see that the problem asked me to round to the nearest hundred, so they want my answer as a decimal anyway. So at this point, I might as well go ahead and throw this into my calculator and find out what the decimals are. So now, remember that this plus or minus symbol over here in the middle means that this is the part where I split my solutions up into their two possibilities. So either x is 2 plus the square root of 76 over 6, or x is 2 minus the square root of 76 all over 6. When you put this in your calculator, if you're going to use the division bar for instead of the fraction bar, make sure that you put this value in parentheses so that it divides the whole thing by 6 and not just the root of 76 by 6, okay? Same thing down here. If I put this in my calculator correctly, I'm going to get 1.78629. I don't even need any more numbers for that 2 plus value. And now it's asking me to round to the nearest hundredth. Don't lose a whole point because you're rounding incorrectly, all right? So the hundredths place is the one here where the 8 is, which means that I'm looking at the 6 to tell me what to do, right? So if this value here that I'm highlighting green is 5 or higher, that means that I move that 8 up a digit, and it is. So this is going to round to 1.79. So that's one of my values of x. And then for the other one, if you calculate correctly, you should get negative 1.119, yada, yada. And it wants us to round to the nearest hundredth. So again, this one right here is the hundredths place, which means that I'm looking at the 9 to tell me what to do in terms of rounding. So because the 9 is higher than 5, it means that I move that 1 up to a 2. So x equals negative 1.12 is my second value of x here. All right, if you want to throw this straight into your calculator as one expression, we can do that. So let's go ahead and hit alpha y equals and number 1 or enter to get ourselves a fraction. And now we can start substituting everything in. So we had a negative 2 plus, so we do have to put this in twice, right? Because we have the plus and then we have the minus. So we'll start with the plus. The square root, so second x squared, the square root of b squared. Again, those parentheses are vital. Our b was negative 2. Close those parentheses and put the square sign after it. Minus 4 times our a was 3 and our b was negative 6. Make sure you're using a minus sign and not a negative sign. Okay, now we're going to go down to our numerator and do 2 times 3. All right, enter, and there it is. The same value that we got before, rounded to the nearest hundredth, would give us 1.79. So same exact process for doing the minus option, and you will get negative 1.12 when you round correctly. Now, if you have some extra time on the Regents, I'm always going to suggest checking. So hit your y equals, type in the equation of the quadratic, let's graph it and see what this parabola looks like. Okay, so now I'm zoomed in so that I could see my x-intercepts. So according to our solutions, when we use the quadratic equation, we're supposed to get the values of x being around 1.79. So that would be a number that is between 1 and 2, closer to 2. Well, look at the graph. That x-intercept does look like it is between 1 and 2, but closer to 2. The second x-intercept that we had was a number that was around negative 1.12. So that value would be just a little bit to the left of negative 1. And as you could see, the second x-intercept in our graph does look like that. So this doesn't tell me that I'm accurate in my answer for sure, but it does at least tell me that my answer is certainly reasonable. Number 30 gives us a piecewise function and asks us to state the value of f of 3. So with piecewise functions, there are always multiple rules, right? And where you replace x depends on which of these inequalities the x that you're given satisfies. So we're looking for f of 3, right? Meaning, what is f of x when x is 3? Well, where would 3 fit here? Does 3 make this inequality true? Or does 3 make this inequality true? 3 is not greater than 3, so that one is out. 3 is less than or equal to 3 because of that or equal to. So because the 3 fits in that second inequality, that means that the rule that I'm following is this rule given here. So all I have to do now is substitute. So to find f of 3, I'm going to substitute into this highlighted expression 3 for my x value and evaluate. So 3 squared is 9. Going to bring down that negative sign, or in essence multiply the 9 by negative 1, bring down the plus 15, and that gives me a value of 6. So f of 3 for this piecewise function is 6. Number 31 wants us to express the given equation in the form x minus p squared equals q. So the way that we can achieve that format is by completing the square. The way we complete the square is like this. You're going to take the b value, which is the coefficient of x, and we're going to take half of it. So we're going to divide it by 2, and then we're going to square that value. So if I take half of b and I square it, that gives me negative 4 squared, and that is 16. Okay, now once we have that value, b divided by 2 squared, we're going to take that number and you're going to add it to both sides of the equation. So I'm putting plus 16 on the left side, and now I'm also going to put plus 16 on the right side. Okay, on the right side, let's go ahead and simplify that to negative 25. And on the left side, now I want to factor this. So when we do product and sum, you're looking for two numbers that give me a product of 16 and a sum of negative 8. I don't have to think too hard because the whole point of completing the square is that it results in a perfect square trinomial. So the two numbers that we're looking for are always going to be the same number. So I'm going to write this as x minus 4 times x minus 4, right? When I add negative 4 plus negative 4, I get the sum of negative 8. And when I multiply negative 4 times negative 4, I get the product of positive 16. So now it doesn't quite look like the highlighted green equation yet, but what I notice is that x minus 4 is being multiplied by itself. And when something is being multiplied by itself, that's the same thing as squaring it. So I can rewrite that as x minus 4 squared equals negative 25. And now you notice that the equation we have looks just like the format that they asked us for in number 31. The last question in part 2 asks us to factor 36 minus 4x squared completely. So always check to see first if there's a GCF that you could factor out. So I noticed that between these two terms, there is a common factor of 4. So I'm going to factor out that 4 by dividing each of these terms by 4. So 36 divided by 4 is 9. Negative 4x squared divided by 4 is negative x squared. So I've factored out that 4, and I see that if I was to distribute that 4 into the parentheses, I would get a 36 here for the first term, and then 4 times negative x squared would give me negative 4x squared. So I factored by GCF, but I'm not done because what I notice is that now the terms that are in the parentheses, the expression that's in the parentheses, looks an awful lot like something that I could use the difference of squares formula on. So if you need a refresher, the difference of squares formula says that if you have an expression that looks like this one in red, a squared minus b squared, then to factor it, it would be equivalent to a plus b times a minus b. So looking at the expression in our parentheses, we have 9 minus x squared. I know you think you only see one exponent of 2, but I can rewrite this as 3 squared minus x squared. And now it becomes easy to see that that is my a value and that is my b value. So I do indeed have an a squared minus a b squared. So now I can rewrite this using the formula from above. It says a squared minus b squared equals a, which is 3, plus b times a minus b. So the parentheses, the expression that's in the parentheses, will be factored to equal the expression I just boxed off in red. So let's come back to our work in the blue. We can't forget about that 4, right? That 4 is part of our answer. But we're going to rewrite this parentheses as 3 plus x times 3 minus x. And now we have completely factored